Step 3 in Spanning Tree Protocol is to find the root port for every switch. Now this does not include the root bridge itself, but every other switch. Where is the root port on that switch? So let's take a look at that in a little bit more detail. Every port, as we already said in our last video, on the root bridge will be active and designated port. However, the designated port on the other switches will be the port that has the lowest cumulative cost to the root bridge. Now, in this case, I'm saying that all of these are gigabit Ethernet connections. The gigabit Ethernet connection has a cost of 4. So let's take a look at each of these switches. Switch 0 here, well, it can get to the root bridge. Remember that the root bridge is this one up here, this one, the switch 3 in the upper left corner. So switch 0 can get there in this one hop here, and this happens to be a cost of 4 because it's a gigabit connection. Now, if it went up here to switch 4 and then over to switch 3, we'd have to have a cost of 4 for this link in the middle here and another 4 to get from 4 to 3. So that's 4 plus 4. That would be a cost of 8. And so we know that this root port, this port here on this switch 0 is the root port. Down here on switch 2, this port in the corner has a cost of 4 to get up to the root bridge. Any other direction, it would take 8. Well, it could even take more than that, couldn't it? If it went from switch 2 to 0 to 4 to 3, then that would be 4, 8 from 0 to 4, and then 16 from 4 to 3. So that'd be a cost of 16. So this is the lowest cost route from corner to corner here. And then for switch 4, again, we have a direct line from 4 to 3 on this line at the top. And so that's going to become the root port. So each switch now has a root port with the lowest cost. However, let's take a look at this diagram over on the right. We have taken out one of these lines, and when maybe it went down and Spanning Tree had to renegotiate, or maybe it's just a different network. But now we have a little bit of a change here. In this case, switch 0 still has the same root port, and switch 4 up here at the top still has the same root port. But switch 2 no longer has that corner-to-corner link that we had over here in the last diagram. So it does not have a cost of 4 to get to the root bridge. It can go 8 by going from switch 2 to 4 to 3. That's a 4 on the right-hand link here and 4 on the top link. Or it could go 8 from switch 2 to 0 and then 0 to 3. So there'd be 4 down here, 4 over here. That would be 8. So they're both 8. So what's next? How do we decide? The tiebreaker is the lowest neighbor bridge ID. So here, switch 4 has a bridge ID of 32768 AAAAAA and so on. Switch 0 has a bridge ID of 32768 DDDDDD. Well, it's the one up here in the upper corner has the lowest bridge ID. So remember, it says neighbor bridge ID, not itself, but the neighbor bridge ID. In other words, the way the one that has the lowest bridge ID that leads directly to the root port. So it's going to choose the root port as this upper one here, the one along the left. That port will become the root port on this particular switch.